Hello students and welcome to my channel Elevate Learning with Santosh sir. Today we will be learning SSC grade 10 algebra, the first lesson linear equations in two variables, and this is the part 1 of the chapter. If you wish to learn with me online, you can fill the form given in the description box. You can also connect me on my number given in the description. At the end of this module, you will be able to understand linear equations in two variables, and also you will be able to solve simultaneous linear equations by elimination method. Let us begin. Linear equations in two variables. An equation which contains two variables and the degree of each term containing variable is 1 is called linear equation in two variables. We can have some example over here. If we look at the first example, it contains two variables and degree of the term containing variable is 1. So it is a linear equation in two variables. In the second example, again it has two variables and the degree of term containing variable is again 1. So it is a linear equation in two variables. Also, in the third example, we have two variables and the degree of term which contain variable is 1. So all three are linear equations in two variables. Let's move ahead. The standard, or we say general form, is ax plus by plus c is equal to 0, where a, b and c are real numbers. In the place of a, b and c, we will have numbers and we will have two variables in the place of x and y. The only condition is both a and b should not be 0 at the same time. So any equation which looks like ax plus by plus c is equal to 0, where in the place of a, b and c you have numbers and in the place of x and y you have variables, can be called linear equation in two variable. One thing to remember is value of a and b both cannot be 0 at the same time. If one of them is 0, it's okay, but both cannot be 0 at the same time. So these are few examples. Both the examples over here are linear equation in two variables. You can clearly see they have two variables and in the place of a, b and c we have numbers in both the equations. And let us see some examples of equations which are not linear equations in two variable. For example, if we see the first equation over here, the highest power on the variable is 2. So it is not a linear equation in two variable. In the second example, if I bring x in the numerator, it will become x raised to minus 1 plus 5 raised to minus 1 is equal to 4. But what we have learned, the degree of the term containing variable should be 1. Over here it is minus 1. So this is also not a linear equation in two variable. Let's take up the third example over here. In this example, in the first term, the degree is 2. That is 1 for x and 1 for y. So the degree of the first term becomes 2, because of which it is not a linear equation in two variable. I hope you understand what is a linear equation in two variable and what is not a linear equation in two variables now. Let us proceed. Important points to remember. We can always multiply or divide both sides or throughout of an equation with the same number for the purpose of solving the equation. For example, if I have an equation 3x plus 4y is equal to 2, I can multiply throughout by 2. In this case, each term will be multiplied by 2. So we will get 6x plus 8y is equal to 4. We can do this for the purpose of solving. Let's take another example. A plus b is equal to 6. If I multiply throughout by 5, what will it become? It will be 5a plus 5b is equal to 30. Here I have 5m minus 30n is equal to 50. If I look at the three numbers over here, each number over here is divisible by 5. So I can make it simple by dividing throughout by 5. So what will happen? 5 divided by 5 will give me 1. 30 divided by 5 will give me 6. And 50 divided by 5 will give me 10. So we will get m minus 6n is equal to 10. We can do this for the purpose of solving. Next important point to remember is we can always shift the terms from LHS to RHS or from RHS to LHS for the purpose of solving. For example, 3x plus 4y is equal to 2 can be written as 3x is equal to 2 minus 4y, and then if I take this 3 on the other side, I can say x is 2 minus 4y upon 3. We can do this for the purpose of solving. Second example, if a plus b is equal to 6, we can say that a is equal to 6 minus b, or we can also say that b is equal to 6 minus a. Taking a on the other side, I will get b is equal to 6 minus a. Let's have this example. Now over here each number is divisible by 5. So first I divide throughout by 5 to get m minus 6n is equal to 10, and then I can get m is equal to 10 plus 6n. So we will use this while solving the problems, children. So these are some intermediate steps that we will be using. At that time we should not be confused. So remember, you can multiply or divide an equation by the same number throughout, or you can shift the terms from one side to the other for the purpose of solving. Let's proceed. In this chapter, we will cover various methods of solving linear equations in two variables. They are elimination by equating the coefficients, substitution method, graphical method, Cramer's rule, reducing to linear equations by substitution method, and at the end we will see the application of simultaneous linear equations in real life problems. Let us start with our first method, that is elimination by equating the coefficients. We are starting with the practice set 1.1. Let's see the first question. We have two linear equation in two variables given to us. The first equation is 5x plus 3y is equal to 9, and the second equation is 2x minus 3y is equal to 12. In this method of elimination, we try to make or we try to find whether coefficient of any one of the variable is same in both the equations or not. If we concentrate in the first equation, I have 3y, and in the second equation I have minus 3y. So now if we add the two equations, then plus 3y minus 3y will get cancelled. So we can eliminate y by adding these two equations. So when we do this, adding equation 1 and 2, we'll write the first equation, we will write the second equation. Now minus 3y and plus 3y can get cancelled. 5x plus 2x will give us 7x, and 12 plus 9 will give us 21. So we will get 7x is equal to 21. Now we can easily shift 7 on the other side to get the value of x as 3. As soon as I get the value of x as 3, I can use this value of x in any one of the equation given above. For example, this time I am using x is equal to 3 in the second equation. So I'll write the second equation. In that, in the place of x, I will put 3, and then I will solve it. 2 3s are 6. I will get 6 plus 3y is equal to 12. Then I can say that 3y is 12 minus 6, which is nothing but 6, and y is 6 upon 3, that is nothing but 2. So the solution to this is x comma y is equal to 3 comma 2. Let's take up one more example. We will do the second question of the practice set 1.1. Here 3a plus 5b is 26, and a plus 5b is equal to 22. We can see that the coefficient of b is same in both the equation, but this time the sign of the coefficient is also same. So if we add 5b plus 5b will become 10b. It will not get cancelled. So in such condition, we can subtract the two equation. Always subtract smaller equation from the bigger equation. So here we subtract equation 2 from equation 1. So we will write the equation 1, we will write the equation 2. Now as we are subtracting, sign of each term of the second equation will change. Plus a will become minus a, plus 5b will become minus 5b, and plus 22 will become minus 22. Now we can clearly see that plus 5b and minus 5b can get cancelled. 3a minus a will give us 2a, and 26 minus 22 will give us 4. We can say that a is equal to 4 upon 2, which is nothing but 2. As we get the value of a, we can use this value in any one of the equation to get the value of b. This time I am using a is equal to 2 in the second equation. So in the place of a, we will have 2, and then we will shift this 2 on the right side. We will get 5b is equal to 22 minus 2, that is 20, and b is 20 upon 5, that is nothing but 4. So we can say that a comma b is equal to 2 comma 4 is the solution. So what did we learn till now? If the coefficient is same and the sign is same, we will have to subtract. If the coefficient is same but the sign is different, we can easily add. Now let us take the next example. X plus 7y is equal to 10 and 3x minus 2y is equal to 7. Over here, we could not find any of the coefficient same. Here we will have to work out a bit. We will try to make the coefficient of any one variable same. In this case, we are multiplying equation 1 by 3. Remember in the beginning I said that we can multiply the equation by the same number for the purpose of solving. This time I'm trying to make the coefficient of x same in both the equation. In the second equation I have 3x. In the first equation I have only x. So I am multiplying equation 1 by 3 so that I get 3x in the first equation also. So if I multiply equation 1 by 3, each term will be multiplied by 3. 3 into x will give me 3x. 3 into 7 will give me 21. And 3 into 10 will give me 30. With the help of this, I will get a new equation. 3x plus 21y is equal to 30. Let us mark this new equation as 3. Now look at the equation 3 and look at the equation 2. We have 3x in both the equation. But over here, the sign of 3 is also same. In this case, we will subtract the two equation. Always subtract smaller from the bigger equation. So here, we will subtract equation 2 from equation 3. We will write the equation 3, we will write the equation 2. We know that we are subtracting, so we will change the sign. Plus 3x will become minus 3x, minus 2y will become plus 2y, and plus 7 will become minus 7. Now when we solve it, plus 3x and minus 3x will get cancelled. 21y plus 2y will give me 23y, and 30 minus 7 will give me 23. Here we can solve it by y is equal to 23 upon 23, which is nothing but 1. Now we got the value of y as 1. We can use this value in any one of the equation 1 or 2 or 3. I'm putting y is equal to 1 in equation 2. Now 3x minus 2 into 1 is equal to 7. We know that 2 ones are 2. I'll get 3x minus 2 is equal to 7. If I take minus 2 on that side, I get 3x is equal to 9. Then x becomes 9 upon 3, which is equal to 3. So x comma y is equal to 3 comma 1 is the solution. Let's take up the next question. Here 2x minus 3y is 9 and 2x plus y is 30. Luckily, we have 2x in both the equations. This time the sign is also same. So we can subtract the two equations to solve. Always subtract smaller from the bigger. So we will subtract equation 1 from equation 2. We will write the equation 2, we will write the equation 1. As we are subtracting, we will change the sign, and then plus 2x and minus 2x will get cancelled. Plus y plus 3y gives 4y, and 13 minus 9 gives 4. We get the value of y as 1. We can use this value of y in any one of the equation 1 or 2. I'm using this in equation 2. I'll put 1 in the place of y, then I'll solve it ahead to get the value of x as 6. The solution is x comma y is equal to 6 comma 1. Let's take the next question. 5m minus 3n is equal to 19 and m minus 6n is equal to minus 7. Over here, we could not find any coefficient same. So we will have to make them same by multiplying any one of the equation. This time, I select the equation 1 and multiply it by 2. If I multiply equation 1 by 2, each term will be multiplied by 2. 5 will be multiplied by 2 to get 10. 3 will be multiplied by 2 to get 6, which will make it same as n in the second equation. And 19 multiplied by 2 will give me 38. Now, on multiplication, I get 10m minus 6n is equal to 38. Now, we have minus 6n in the third equation and minus 6n in the second equation. Since the sign is same, we will have to subtract, and always subtract smaller from bigger. So we will subtract equation 2 from equation 3. We will write the equation 3, we will write the equation 2. We will change the sign because we are subtracting. This time minus 6n and plus 6n will get cancelled. 10m minus m will give us 9m, and 38 plus 7 will give us 45. We can take 9 on the other side. We can say m is equal to 45 upon 9, which is nothing but 5. Using this value of m in the equation 2, we can get 5 minus 6n is equal to minus 7. We can say that 6n is equal to 5 plus 7. So 12 is equal to 6n. 12 upon 6 is equal to n. We get n is equal to 2. Solution is m comma n is equal to 5 comma 2. Let's take the next problem. 5x plus 2y is equal to minus 3 and x minus 5y is equal to 4. Here, none of the coefficients are same, so we will have to make them same. This time, I'm multiplying equation 2 by 5. If I multiply equation 2 by 5, I will get a 5x over here, which will make it similar to the first equation. So, on multiplying equation 2 by 5, we get 5x plus 25y is equal to 20. Now, we have 5x over here, we have 5x over here. Since the sign is also same, we can subtract the two equations. So, always subtract smaller from bigger. We will subtract equation 1 from equation 3. We will write the equation 3, we will write the equation 1. This should be 1, and then we will change the sign because we are subtracting. Plus 5x and minus 5x gets cancelled. 25y minus 2y gives 23y, and 20 plus 3 gives 23. Y becomes 1, and then using this value of y in equation 2, we can get x is equal to minus 1. So the solution is x comma y is equal to minus 1 comma 1. Let's take up the next example. Here 1 upon 3x plus y is equal to 10 upon 3 and 2x plus 1 upon 4y is equal to 11 upon 4 are the two equations given to us. We can clearly see that both the equations are a little complex. So first we will have to make them simple. Remember in the beginning when I was showing important points to remember, I said that we can multiply an equation with the same number throughout. So I want to get rid of the denominators in the first equation. So why not to multiply the first equation throughout by 3? If we multiply first equation throughout by 3, each term will be multiplied by 3 and the denominators will get cancelled. We will get x plus 3y is equal to 10. We have made the equation 1 simple and we have marked it as equation 3. Can you think of a number which can eliminate the denominator of the second equation? Yes. We can multiply second equation by 4. If we do so, we can cancel out the 4's and we can get rid of the denominators. We will get 8x plus 11y is equal to 4 as the fourth equation. Now, once again, the coefficients are not same, so we will have to make them same. What we can do here is, we can multiply equation 4 by 3. If we multiply equation 4 by 3, we will get 24x plus 3y is equal to 33. Now, if you observe 3y in the equation 5 and 3y in the equation 3, we can do something over here. Since the sign is also same, we can subtract these two equations. Always subtract smaller from bigger. So we will subtract equation 3 from equation 5. We will write equation 5, we will write equation 3. As we are subtracting, we will change the sign. 3y and minus 3y will get cancelled. 24x minus x will give us 23x, which is equal to 23. X becomes equal to 1. We can use this value of x in equation 3. In the equation 3, we will put 1 in place of x. So we will get 1 is plus 3y is equal to 10. And on solving this ahead, we will get y is equal to 3. So the solution is x comma y is equal to 1 comma 3. Let's take up the next question. Here, now this question is typical. If you observe very carefully, 99x plus 101y is equal to 499 and 101x plus 99y is equal to 501. If you see, the coefficient of x in the first equation becomes coefficient of y in the second equation, and the coefficient of y in the first equation becomes coefficient of x in the second equation. What we observe here is that the coefficients are exchanged. Whenever you have such type of simultaneous linear equation, I recommend you to go with this method, which I call ASA method. Now, what is that? ASA method. First, A stands for add, S stands for subtract, and the third A again stands for add. We will be following these three steps to solve such equations. So what is the first step? A, that is add. So let us add equation 1 and we'll write the equation 1, we'll write the equation 2. On adding, we will get 200x plus 200y is equal to 1000. If you observe the equation carefully, each number over here is divisible by 200. So we can divide throughout by 200 to get x plus y is equal to 5 as a simple equation. Now we go to the second step. After A, it is S. So now what we will do? We will subtract the equation 1 from 2. When we do this, we will write the equation 2, we will write the equation 1. As we are subtracting, we will change the sign. Now 101x minus 99x will give us 2x. 99y minus 101y will give us minus 2y, and 501 minus 499 will give us 2. So we get 2x minus 2y is equal to 2. Once again, each number over here is divisible by 2. So we can divide throughout by 2 to get x minus y is equal to 1. So after adding, we get a simple equation. After subtracting, we get a simple equation. Now we will go to the third step, that is A. ASA. A is done, S is done. Now we are coming to A. In this case, we will add the two simple equations that we have got. So we will add the equation 3 and 4. We will get x plus y is equal to 5, x minus y is equal to 1. We can easily cancel plus y and minus y. We can get 2x is equal to 6, which will give us x is equal to 3. Once we get the value of x, we can use this value of x in any of the simple equations. Don't go in first and second equation, they are difficult. Go for any one from third and fourth. So I am going with the equation 3. In the equation 3, I'll put 3 in place of x. as x is 3. So x plus y is equal to 5 becomes 3 plus y is equal to 5. So y becomes equal to 2. Hence the solution is x comma y is equal to 3 comma 2. Let's do one more problem of such type. 49x minus 57y is equal to 172 and 57x minus 49y is equal to 252. We are following ASA method as the coefficients over here are exchanged. So first A stands for adding. So we will add the equation 1 and 2. On adding, we will get 106x minus 106y is equal to 424. Each number over here is divisible by 106. So we will divide throughout by 106 to get x minus y is equal to 4. So first step is done. Now the second step says to subtract. We will subtract smaller equation from the bigger one. So we will subtract equation 1 from 2. We will write the two equations. We will change the sign and then we will solve it to get 8x plus 8y is equal to 80. Here each number is divisible by 8, so we can divide throughout by 8 to get x plus y is equal to 10. Now by adding we get a simple equation, by subtracting we get a simple equation. Now let us proceed to the third step, that is add. We will add these two simple equations, then plus y and minus y will get cancelled. We will get 2x is equal to 14. So x becomes equal to 7. Using this value of x in the equation 4, we can say that 7 plus y is equal to 10. So y is equal to 3. So the solution is x comma y is equal to 7 comma 3. Let's come to the next question. Here 13x plus 11y is equal to 70 and 11x plus 13y is equal to 74. Again, it is a type of ASA method problem. You can pause the video and give it a try, and later on you can tally your answers with mine. Let us start the discussion. Once again, I'm going for ASA method. So we will add the two equations first. We will get 24x plus 24y is equal to 144. Or dividing throughout by 24, we will get x plus y is equal to 6. Then we will subtract the two equations. We will get minus 2x plus 2y is equal to 4. On dividing throughout by minus 2 or 2, you can also divide it by 2. I am dividing it by minus 2. I will get x minus y is equal to minus 2. We got two simple equations. Now we can add these two simple equations to get the value of x as 2, and we will use this value of x in the third equation to get y as 4. So the solution is x comma y is equal to 2 comma 4. So here we complete the module of elimination method. If you have understood each and every problem, you can like this video and share it with your friends. I will also be uploading more videos on the different topics of algebra and geometry. So you can subscribe my channel and press the bell icon. Once you press the bell icon, you will get the update of my new videos in the notifications. If you want to learn from me online, you can join me by filling the inquiry form given in the description box. You can also collect me on my number which is given in the description. In the next session, we will start with a new method of solving simultaneous linear equations. Till then, take care. Thank you.